Good evening, everybody, and welcome to part 3 of the VIC administration vBrownBag with Cody De Arkland. We're very excited to have him this evening. Part 3 is a little bit of an outlier because we did not intend to have a part 3. In fact, what we're going to be doing this evening is we're going to be reviewing, if you watch the previous episodes, we're going to be reviewing everything that blew up in part 2, explain why they blew up, and then actually do them for realsies so that the stuff that we had planned on doing in part 2 actually gets knocked out, and Cody becomes a happy presenter because he was very upset. With that, let's do a couple of housekeeping issues. If you want to chat with us, we always love to hear from you. Please send us a Twitter. Please don't
send us any twits. Please don't send us any twits.
No twits.
That would be. Most of us have to deal with those between 8 and 5 anyways. No twits.
Forward us all of your twits too at Cody De Arkland.
No, you're missing the point, Chris.
Oh,
no.
I'm sorry. Wait, what? At vBrownBag.com. Tweet us. I will be responding. Or if you feel like irritating me directly, especially the twits, don't send any twits to Cody. Send them to me. Tonight we've got Cody De Arkland. I am Mistwire. With that, with the shenanigans out of the way, let's get on to some more fun shenanigans. Cody, you are the presenter, sir.
All right. See if I can beat the GoToMeeting monster. All right, are we seeing my screen?
I can see your screen, yes.
Fantastic. So taking a step back, what was originally supposed to happen in part 2 is we were going to recap the fact that we had deployed a vSphere integrated container, which are VMware's answer to kind of the Docker question and the ability to host Docker-enabled endpoints directly on ESXi hosts. So the ability to hit a API gateway, provision Docker hosts, and do Docker-ish things, persistent volumes and data stores and all that kind of magic directly on an ESX host. And it was going to be magical and great, except for I fell flat on my face like 7 times in a row and couldn't figure out why. And then spent an hour with Chris and I think 11 other people that hung out an extra hour later trying to figure out why.
Set a brand new record.
Right. So the ultimate lesson here is something that all administrators learn at one point or another, and that's that copy and paste can be your best friend or your absolute worst enemy. So we're gonna talk a little bit about what part failed, and we're also going to go through and show a successful implementation. Mostly what we were trying to show was the ability to manage Docker containers and or Docker hosts and vSphere integrated container hosts within the VMware toolset, and do things like present a network to a container host and have containers get actual IP addresses, or utilize persistent data with a data volume. So we're going to show a little bit of that tonight, and we're going to dig into how we can manage containers through our Admiral product, and how we can manage images and consume images with vSphere integrated containers inside of our Harbor product. So our being VMware, because that's where I work. So I have the GitHub page up just so that while I was rambling along, you guys could be looking and seeing what that was all about. But let's jump into some fun. So last week we talked a lot about the VIC machine commands. So we look inside our VIC directory that we freshly exported. You'll see some content in here. We'll see some of the old hosts that we had deployed that we'll go ahead and get rid of now. There we go. So they're gone. We're going to be explicitly working with the VIC machine Linux command. So now, we talked a little bit about this in the first video, but just to recap, if we go VIC machine Linux, and we do help, you can see the commands that are available for it. We're primarily going to be working with the create command and the delete command. Obviously, all of these other commands do things, but for the purposes of this conversation, we're going to be working with these commands. Now, if we do a VIC machine Linux create sh, we get a simple help file But this isn't going to answer all of the questions that we have. There's a lot of commands that are additional things you can do with the container host that we can't really see here. So if we do a -X for extended help, you can see we get a whole lot more options, things like setting size limitations, CPU shares, CPU available memory reservation. We can dig into a number of different network configurations from bridge network, and bridge networks are how the containers talk to one another across the Docker bridge. We can specify specific ISOs to load and so on and so forth. For purposes of our conversation, I've kind of pulled out the main commands we were going to work with. Those are right here, and we'll step through what those actually mean, and then I'll also highlight where my failure was from last week. So target refers to specifically the vCenter or ESXi target. You can deploy VIC against an ESXi host without vCenter if you want to. That's totally supported and a workable thing. It just requires enterprise licensing. In our case, we're going to use a vCenter endpoint, so we'll go plug that in there. We're going to use our administrator credentials. We're going to name the host. We want to give it the cert a specific name. For compute resource, because we have multiple hosts and clusters, we're going to use my management cluster, which we can briefly see right here. Image store relates to where images are saved, so that for future machines or future VIC builds, they can consume the same image store. So we'll go volume stores for persistent volumes, so that, for example, if you were working with an Nginx server and you stood it up and you mapped that persistent volume for the conf.d directory, so you wanted to make some specific changes to the way web pages respond inside of Nginx, but then you destroy your Nginx container. If you had that mapped to a persistent volume store, when you built a new Nginx container and pointed it at that volume store, it would actually retain the data. I believe that there's a future session that includes that topic and the concept of persistent volumes and containers, so I don't want to steal that individual's thunder, so I'll just say that it exists and it will be covered. We're going to consume it inside of this presentation, though, by just throwing that tag around that. Public network is the IP address of the actual container host. It's also when you're not specifying a management IP or any of the other commands that we have here, some of the different network commands. So we have client network, we have public network, we have management network. If you're using public, it acts as both client and management as well. So we just use public to make things simple. So we're going to go via network to specify a port group inside of ESX. We're going to give it an IP address, and also the CIDR block that it's associated with, and then also the gateway that exists also. We're going to give it DNS so that we can actually do name resolution. Our bridge network, again, is the network that containers speak to across each other. It's interesting, and I covered this in the first video, and I'll briefly cover it here. I had a lot of problems deploying VIC the first time in my lab, and it took me a long time to figure out why, and it's because the default VIC network is a 172.16/16, and I have an actual lab network that lives within that range, so when the container would come up, it was not able to actually communicate, so I needed to, once I discovered that that was an actual network that Docker was trying to use, I found out that I could use the bridge network command to actually change the default bridge network. So I use 192.100, not 168, because that would cause me a lot of pain too.
Right.
For obvious reasons. Oops. See? I make one mistake and it all goes down the hill. We plug that into the bridge network range. For bridge network, we use our bridge port group, which we can actually see inside of my network. I just made a simple VIC bridge off of my existing NSX VDS, and it has no VLAN tag to it. It's just an isolated little VIC bridge hanging out. Now this is where we made our big mistake. My command before looked like this. My command now looks like this. In order to consume local networks and consume regular networks that are outside of the traditional Docker scope, we call those external networks, you have to call those out as part of the actual VIC creation. So we had to actually create this during the build as a container network. Now, in here, we're going to point out the actual port group, which we've created as LAN VDS. Again, we pop back in. You can see LAN VDS here. This network is trunked to all VLANs. So it has everything available, but DHCP is active in there, so when we create containers, it'll actually grab an IP via DHCP when we use that. We do know TLS verified, so that, oh, go ahead, Chris.
Do you have a VM kernel attached to that port group, or does VIC take care of everything?
VIC will take care of everything. So VIC will actually, because it's going to come up, once VIC comes up, its containers are going to start, because we're going to actually, when we run those containers, we're going to use the way we're going to set it up inside of Admiral, we're going to map it down to that network. So it's similar to using like the --net command inside of Docker, if you ever use that to map to an existing network. It'll make sense when I show you a Docker network ls command after we create this container host, and because you'll see that the actual network exists.
Gotcha. Will those, so multiple containers across multiple hosts will all be able to utilize that?
Correct.
Okay, cool. That's awesome.
Yeah, so and that's where it gets really interesting when you start tying it into NSX, right? Or something we were talking about earlier, VROPs, right? So having these machines have their own address. Already VROPs can be consumed. Or NSX, or I'm sorry, VIC can use.
Cody, you sound very far away all of a sudden.
Oh, not sure why that happened. How's that? Better?
There you go, much better.
Cool. VIC by default is set up to where things like VROPs and log insight and such can consume it, but when you want to get into having NSX actually consume VIC hosts and more so containers that are deployed as VIC, deploying them onto an NSX virtual wire, you can start to get really creative. You know, one thing that I did in my lab with my Alexa project, having it actually talk, or having an NSX firewall rule in place that would block communication except for to my API endpoints. Mm-hmm. That's something we could see enterprises actually doing, right? And standing up a container that talks over 443 and then saying that this, building an NSX rule that says this container can only talk to these destinations. Some security purists might argue that, well, with VIC, you're only allowing the only ports you needed anyway, so your security risk is low, but anything to move the ball forward is my perspective on the matter.
Right.
So we use no TLS verify because we don't want it to check and see if the certs are valid because they're going to be self-signed. These two commands, insecure registry and registry CA, these are tied back into the way that we consume our Harbor products or any insecure Docker registry. So we're going to go in and we'll do, which is my insecure registry, which we're going to jump into in a few. And I've already installed the certs on this box. So we'll go etc docker certs d. And just a fun little bit of Docker trivia, if you ever need to have an insecure, if you ever want to use an insecure Docker image repository, you can drop the CA cert for that into this directory. So you want to label it with the address you're going to connect from, or I'm sorry, to. So for us, we're going to use the FQDN. And you can drop the cert in there and restart Docker, and it'll trust that cert for image purposes. So we talked before that you wouldn't know the thumbprint by default, that you have to run the command once. It'll crash out and give you the thumbprint to include. I've already copied that, so we don't need to go through that step again. All right. Should be good to go. So we're going to drop in. We're going to build our container now. Plug in our password. And we're off and running now. If we pop into vCenter, we can see it's starting to actually build a container host, doing all of its fun magic. Another interesting fact while this is building out, I had a lot of problems building out my first time as well because it would keep throwing back that it couldn't communicate with vCenter over the API. So naturally, the first place I go is firewall, right? Do I have communication? You know, my ports are open. Why is it doing this? Taking a step back and looking at the science of the situation, our target is a vCenter, but really it's a host name. And before, I was not our last session, back when I first played with VIC the first time, I didn't include this DNS server flag. So it had no DNS because I was explicitly calling out the IP. Now, if I had left all of that blank so that it just grabbed an address off DHCP, it would have been fine. But because I explicitly called out the IP address and gateway, but I did not call it DNS, it never applied to DNS, so it would never talk to the API endpoint.
Gotcha. Okay. It's all coming together now.
So, interesting stuff. Yep. So here's our Docker endpoint. We do a Docker info. It's there. Now here's, go back to what you were asking about, Chris. Network, LS.
Cool.
So now this network lives across, you know, anybody who's consuming this. And really, if I have multiple hosts in this cluster, because of the way, the unique way that VIC is kind of integrated with VMware products and the fact that VIC is designed to use an entire cluster, really this functions a lot like a VDS, and that's why it wants a VDS port group. You know, you have to be using the VDS in order to consume, in a vCenter environment, and consume these external networks, because it's going to communicate across all of the hosts in the environment. So, and then if we go in, we can do a network inspect and look at it. We can see some of the details around what is, but it's pretty blank in this case because we're consuming, right? We're going to land on that network. You can do some basic IPAM on here, and you could throw in and say, you know, these are the ranges we can consume on this network, so on and so forth, but we're not doing that in this case. Another thing to look at, volume LS. Sorry, not network volume. Volume LS. You know, volume's created, but if we do like a volume create, let me do, it's going to error because volume create accepts no arguments. But if we do we can step through, and we could go through the process to create a volume here, but we're actually going to do that inside of the management tool. So at this point, we have our Docker host up and running. It exists. Just to save time, we're going to start pulling down an image right now. We're going to use the Harbor product to pull down our images, and I'll give you just a quick look at what that looks like. So this is our Harbor product from Admiral, or as part of the Admiral and VIC appliance. Harbor's a separate product entirely. You can see we have a few images in here. We're going to work with this image just because it's a simple example, and this is my my Amazon Echo integration kit that I've been building out. You see, Cody's the author. It was created. I pushed a new version on the 16th. The version of Docker it was set up with, what OS underneath, so on and so forth. If we do a Docker login to that point, we can log in successfully, and then we can do we can pull that image actually down to the host so that it can actually be consumed and ran later. Conversely, and I set this up so that I could show demos at the same time. Change the size of this real quick so we can actually see text. Say we had a new container that we wanted to work with. We could do a Docker build and build that container real quick just for just for the fun of it. And then I'm going to show you the ability to push that container into Admiral and have it show up as an available container. Oh. For grins, we will delete things that aren't being used anymore out. This is an H container. Oh. Running. Oops. Killing me. For simplicity's sake, we'll just use the current working version instead of trying to make the hacky version work. And I just want to point out that what this is super secret. So enjoy the vagueness of what that is because it is super secret. There we go. Now again, similar to when we did our Docker pull before, if we do a Docker login, we're not using VIC in this case, we're using native Docker, and we do a login there. We can do, so we just built a container called VIC test1. We go to tag VIC test1, and then the location we want it to go to with the name of what it'll be. You can do a Docker push, same command. It'll push into that enterprise repository. Come on, little fella. Come on, little fella.
You can do it.
Tortoise in the hair.
Come on, you can do it.
After the beating I took last week, every time something takes too long, I feel like it's going to fail.
Don't worry about it. It's all good.
All right, so that finished. Now if we go back to the registry top, you'll see VIC test1 lives in there now. So we successfully pushed that. Now we could pull this to any host we wanted to. We did that kind of backwards because I pulled down PyVA and then pushed something. I really should have pushed something in and then pulled down to show that, but we accomplished the goal. So now on the other screen, we'll see our PyVA is downloaded. So we're going to jump into the management interface now. So we go to management. This is what Admiral looks like. It's very pretty. We're going to add a host. In this case, we're going to go, and I have a DNS reservation set up for this host name to map back to that IP address that had popped up when the VIC was created. So if we look up, see, 61, which is the address that we used in here. With that, we use the default client cert since we set that up during the build, verified successfully and added. That's where things get really cool. because now we have this kind of management tool around managing this actual vSphere integrated container. If we go into networks, we'll see there's the network we created. We can create more if we wanted to, but we'll stick with this one for now. We can also come in and add our registry, so we can do, oops. Now we have that registry available, and if we search for PyVA, you'll see it comes up here. Now we can come in and we can start to fill out this, and we can deploy it in a traditional way, right? We can come in and do everything set up there the way we want. That's awesome, cool. We could link to other containers if we wanted to, but we're not going to in this example. We know it's broadcasting over 443, so we'll open 443. We'll call it use bridge communication or bridge network mode, and we can provision it. It'll go through. It'll build out the host, or it'll build out the VIC container. We can pop into our vCenter. We'll see it actually coming up and building. So it's there. It's starting up. Things are gelling. It finishes successfully. We can see the container. And what's really cool is if we pop into this container, we can actually see the log file after it finishes starting up all the way.
Oh, that is cool.
There we go. So you can actually see the logs directly on the box, which is incredibly helpful for troubleshooting.
Right.
We can see 443 is exposed. So if we go there, it's going to yell about the cert. And it works, and it's using the same host name as the vSphere container host. And that's cool. You know, that's traditional Docker for you. That works. But let's take it a step further. We're done with this now, so we can go ahead and do a stop command on it. At the same time, if we pop in here and we do
By the way, I did already try to look up
PS.
the clarity on your repository, and I couldn't find it. So I'm
it's private.
It's super secret.
It's super secret.
Not telling.
I'll give you a demo after you turn off recording.
Okay, awesome.
So we stop the container. We show it's not running anymore. We can remove the container so it goes away, which will actually purge it out of vCenter. You can see it kills the machine. It's gone. So I mentioned we're going to take this a step further now. So we're going to go to our templates, and we're going to grab that PyVA. We're going to enter additional information. We're just going to save it as a template. We're not going to click anything else. We're going to save it as a template. This is where things get really cool. Because we can take a network, and we can go existing, use LAN VDS, which is the one we already built. We can connect it to there. Now, if we pop into the settings, go and we'll give it a host name. We're going to leave the network mode blank because we're actually going to consume that other network. So we're going to actually have it live right on that network. Now, if we go provision, and the gods have faith in us, and the gods believe in us, we should see it start to build, hopefully. I've been hurt before.
Hit refresh.
You don't tell me what to do.
You ain't the boss of me.
It actually is probably not going to work because I use PyVA as the host name, and I already have that host name reserved, and it's not on that IP address, and it's gonna have an IP conflict.
Oh.
So
Fire up another one.
That was a fail because of the host name I used. Just going to send it spiraling down a sad path of failure.
You fired up a second one with the same name?
No, so I removed the host name out. So
Okay.
I went in here. Oh, no, I did not remove. Oh, no, I thought I did. So we'll save it. Worst case, it'll just fail again twice in a row. Oh, there it goes. So it's actually going to work that time. I did clear that after all.
Cool.
Wait for it. Wait for you, little buddy. Now, if we look at inside of vCenter, we'll see it starting to come online. If we look at it inside the console, it's running. It finished successfully, and if we go over and look at containers, that one's still building because of the IP conflict. It has an address on our network now. And what's interesting is now every port is exposed on that container, but the container is only listening on port 443 because that's how it's designed. So if we go to that address now, there we go.
Nice.
Now, the really cool thing about the container management platform is that we can do this with volumes also, so you'd be able to create a volume. So again, coming into the command line, if we do a volume ls, there's no volumes. We come in here and we create vol using the vSphere driver, and we map it to this host directly. Completed successfully.
A volume that is consumable by the containers?
Yes, so for persistent data.
Ah, I gotcha. Nice.
Now what we could have done is going in templates. If we did that same by the A1 again, which is this template that we already started on. We kill that host name out. We can even go add a volume, use an existing volume, use Cody vol, and we can map that volume in. See, now that volume, it automatically fills that in for us. So we could go map the temp folder to that directory if we wanted to. Oops, I accidentally hit the back key. So. Then if we provision, it'll go out and build that container again using that volume as the persistent volume. So that if we were inside that container, it would have /tmp map.
And for those listening in the future, can you please speak to why it would be important for a temporary container to have a stateful mechanism for storage?
Yeah, totally. So there are a ton of use cases for persistent volumes. Let's think about the concept of you wanted to run Postgres as a container. It's very common for someone to throw a Postgres, the database volume, onto a persistent volume. That way, The rest of the actual database is ephemeral, right? The actual binaries, the installation, the raw database stuff is ephemeral, but the database data is persistent. So now when you spin up another container, you can actually point the database volume to that persistent writable volume, and it'll be able to actually still attach to that database and have your data be intact. Another one that I use in my home lab, that's a great example, is I front end a lot of my home lab services with Nginx, right? So I have a Nginx container that mounts to a persistent volume backend, and now if I destroy that container or I want to go in and update that file, all I have to do is go in and update it on the main host that holds my Docker container and restart the container, and it's going to remap that conf directory and actually get that configuration file. Talking back to the home lab stuff, many of us run Plex for our home video sharing. People will do a Plex as a container and then mount their configuration directory as a persistent volume so that their configuration is always saved. So a lot of it comes down to the stuff, only saving the stuff that makes sense, right? On a Windows system, a traditional Windows system, there's a ton of stuff on there that you don't care about, right? That if it gets blown away, you don't care. There's probably a gig of files that actually matter to you at most versus the 80 gig installation of Windows. Save the stuff that matters.
Exactly. Cool, thank you.
Yeah, that's finished with the volume. Now we can't consume that volume because we can't log into that actual container and play with it. But if we were able to come in that container, we would be able to go to cd/temp, and it would be mapped to this actual container. So, yeah. Again, now you see we have these 3 containers running. Funny enough, look at this one. It's got a new IP address, 220. The other one was 219. So we're consuming more DHCP or addresses from DHCP. So all's good. And that, my friends, is how you don't fail at a demo 7 times in a row. So now, right. So now, in the interest of cleaning up after ourselves, we'll go through and do a Docker, do a VIC machine Linux delete and we're going to fail this on purpose, just so people don't get any cute ideas and say, oh, look, Cody failed the demo again. We're going to fail this one on purpose.
Well, by leaving out the password?
Nope. If you leave out the password, it'll just prompt you for it.
Gotcha.
That's how you get away with not having to hard code a password into the command. Oh, kaboomy.
What?
VIC by default won't let you destroy it when you're running containers already. So it protects you a little bit from destroying something that you might not be that ready to destroy.
Nice.
So we can get around this by doing a force. Now if we pop into vCenter,
they're dead.
We can watch it start to go through and terminate with extreme prejudice.
Nice. Very cool.
There you go. So again, just to close up, we've now, over the course of 3 weeks, we've shown creating a vSphere integrated container host. We've shown some of the basic commands for building one, some of the options we have for building one. We've failed miserably at managing one in the 2nd week. And then the 3rd week, we went back and did all the stuff we tried to do in the 2nd week successfully, things like mounting a writable volume, mounting or attaching to an external network and consuming standard IP addresses that can be consumed by like NSX or things like that. And we've gone through and shown just the general management interface. We've pushed an image into into Harbor for an image repository. We've pulled an image down. We've shown exposing all ports, and we've shown kind of a simple interface for mapping those containers down to volumes and networks. So I feel pretty good about what happened today.
Me too. Excellent work, sir. Thank you very much for coming back in and doing a part 3 to show off the awesomeness that is VIC.
Yeah. Again, here's the GitHub's here. So GitHub, vmware.github.io/vic. Documentation on there is pretty solid. It's good content. Check it out. Enjoy it.
Cool beans. Well, Mr. De Arkland, thank you very much for coming out and knocking this one out of the park. We will put this in the can and have it published very quickly.
Awesome. I'm going to drop my screen sharing.
All right, and thank you everybody for watching another episode of vBrownBag. Have a wonderful evening.